In our discussion of succession, we talked about the different seral stages in succession, normal climax vegetation and animals for that particular area, and a brief discussion on types of changes that do not lead to normal climax, what we referred to as disclimax and edaphic climaxes. The next two topics we want to talk about are, in a sense, edaphic climaxes. One of them caused by a very large change in weather and to a great extent geological formation. The other caused primarily by differences in soil type. The other two types of succession that we want to discuss are a horizontal type of succession that occurs away from a major habitat or a major community. This type of horizontal succession can be seen very clearly with the Great Lakes, where as you go back from the lake, a type of succession occurs that would be similar to the time succession that we discussed with normal ecological succession. The other type of succession we want to talk about deals with altitude. And of course, in terms of altitude, as you go up a mountain, obviously the weather changes drastically, especially, you know this if you've seen any of the weather reports in the summer from Mount Washington, where down here it's in the 80s or 90s and up there it's 45 degrees. But it also, as I mentioned earlier, usually involves a major change in the geology of the substrate as well. In both cases, edaphic climaxes are involved. Let's talk specifically first about horizontal succession. And if you want to think about this, if any of you have been to Lake Ontario or any of the Great Lakes, especially where there are long areas of sand beaches, this is a classic habitat to see this kind of horizontal succession involved. Now remember again, this is not a time succession. In this case, it's a major change between two types of large communities. Now as you come back from the lake, obviously the first thing that's present that you see is no vegetation and simply a lot of sand. As you get back further from the sand, that sand changes texture and some soil starts to appear. Well, as soon as there is some kind of organic matter available and therefore some nutrients, you see the first stage in this horizontal succession. In this particular case, it involves various types of beach grasses. These beach grasses then extend back away. Remember, we're going away from the lake. These beach grasses extend for some distance from the lake. And remember, as they're growing, they're changing the substrate they're growing in. What was pure sand now gets more and more organic matter because these beach grasses die back, decompose, add nutrients, add organic matter, and just like we talked about with normal ecological succession, they change the character of the substrate, the soil that they're growing in, preparing the next stage. In this case, the next stage would be shrubs or small trees. Commonly, you'll see growing different types of poplar or cottonwood. They too lose their leaves, the leaves decompose, again further changing the substrate. And as you go further away from the lake, the cottonwoods and poplars are taken over by different types of evergreens, usually pines. Now, depending on the area, they may be more jack pines. White pines in some areas become very common. This drastically changes the substrate because now you're adding needles to decomposition, usually more acidity. You have the leaf litter from some of the hardwoods that remain, the needles, the understory of some remnants of beach grasses. And this change makes a major change in the substrate now that you are no longer primarily sand, but you're now building up a substantial soil substrate. This, and it may go through a few more horizontal successional stages, in some cases yes, in other cases no. You'll go directly into the climax vegetation for that area. If you're talking about most of the areas around Lake Ontario, it will probably be primarily maple and beech. In other areas it may be oak hickory. But you can see the parallel that we've drawn. When we talked about normal succession going from pioneer through all of the stages to finally the climax stage, In this particular case, the pioneer stage and the moss stage aren't present. We go straight to the grass stage, shrub, young tree, and finally into the climax vegetation. Not time-lapse, but on a distance basis between two communities. A similar type of situation occurs with altitudinal zonation. Remember again, edaphic. And in this case, it is elevation that causes the change in the various stages in succession. In a sense, almost a reverse, because rather than starting at the bottom of the mountain and working up, like we started at the lake and worked back, we'll start at the top of the mountain and work down so that we can keep those stages in their normal procession the same as they were for normal ecological succession. Now first, when we're talking about altitudinal zonation, we're talking about a mountain range or a mountain itself that's high enough to show all of the stages. In our area, a good example in the Adirondacks would be Mount Marcy, because at that latitude, that mountain has to be over 4,000 feet to show the earliest stage. Obviously, latitude is important. The further you go north, the less the altitude has to be to show the earliest stage. The further you go south, the higher it has to be to show this earliest stage in succession. The first stage, starting at the top of the mountain, and as I mentioned on Marcy, over 4,000 feet, is known as the Alpine stage. In fact, it is very similar to our major biome to the north, the tundra, up in the Arctic region. In the Alpine zone, transitional zone, the dominant type of vegetation is what you'd find in the Arctic, things such as grasses, sedges, lichens, and mosses. For example, one of the common lichens at the top of Marcy is reindeer moss. Remember, that's a misnomer. It's not a moss, it's a lichen. That reindeer moss is the same type of dominant lichen found up in the Arctic Circle, in that biome. The alpine zone exists only above 4,000 feet. It can be found on Marcy, but so many people have been climbing Marcy lately that they're now pounding this alpine vegetation into submission. It's just about disappearing. But it's still there. Below the alpine, and this is below 4,000, is the next zone, the next stage in succession in a sense. It's the KRUMHOLZ zone. Strange word, a German word, but very descriptive. A loose translation of KRUMHOLZ means twisted stick or branch. And the trees that are found here grow very shrub-like, and they do have gnarled, twisted branches. Dominant vegetation in this area would be dwarf spruces and dwarf willows. Below the KRUMHOLZ zone, further down the mountain, is the Hudsonian zone. This is also known as the subalpine zone, and in this area we're getting into now more of the tree stage, but it's a high enough elevation that it's still very hardy trees. Trees such as hemlocks, pines, and firs that can withstand still very adverse meteorological conditions. That Hudsonian zone then blends as we go further down the mountain into the Canadian zone. This is also known as the montane zone, and here our first hardwoods, other than those dwarf willows, start to appear. Birches now become dominant, but you'll also find some conifers still present, spruce, certain types of balsams. And as you get to the bottom of the mountain, below 2,000 feet, we get into the transitional zone, and this has the normal climax vegetation for that area, as we've talked about before, either beech maple or oak hickory.